Shunt motor supply is given. This is supply voltage. This is total load current. Load is on the shaft. Total load current is divided into armature current and shunt field current. This is self-excited DC shunt motor. The total load current is sum of the armature currents and shunt field current. The total supply voltage will be back EMF of the motor plus brush voltage drop and armature voltage drop. The same supply voltage is applied across the shunt field winding also. So shunt field current directly can be taken as supply voltage divided by shunt field resistance. Shunt field winding is thin wire with more number of turns. Thin wire means cross-sectional area is very small, so that resistance will be very high. More number of turns means that is also resistance is very high. So approximate value is around 200 ohms. So whenever current passes through the shunt field winding, flux will produced in this electromagnet. The same flux is links with the armature conductors. Armature conductor is also carrying armature current. So there will be force developed on these conductors. So that is force equals to BIL sin theta. For force development, there must be flux density. This is the flux density. There must be current in the armature conductors. This is the current in the armature conductors. Length of the conductor is already present, and angular momentum of this armature conductors with reference to flux. So then only force will present. The force will be newtons. So because of this force, the shaft will rotate and the load is also connected on the shaft. So load can be driven. The same DC machine can also be run as a generator and as a motor. For DC machines, these are very important formulas. Power equals to E into I in terms of electrical. Power equals to torque into angular velocity. This is in terms of mechanical. So the correlations between mechanical terms and electrical terms. Torque is directly proportional to flux and current. Developed voltage or back EMF, which is directly proportional to flux and speed. So the relation between back EMF and speed is directly proportional. The relation between speed and flux is inversely proportional, or the relation between speed and current is inversely proportional. So here speed relation is inversely proportional with reference to current. And with reference to torque, the current is directly proportional to torque. In between torque and speed, torque is inversely proportional to speed. So these three are very important formulas while dealing with DC machines. Whereas torque is force into radius. This is radius of armature. This is force on each conductor of armature. So force equals to BIL sin theta. For force development, there must be flux density, which can be obtained from field poles, current in the armature, length of the armature, angular moment of armature within the flux, where E can be either it can be generated voltage or it can be back EMF. But in both the cases, the formula is same, pi Z N P pi 60A. So voltage will developed or back EMF will present only when flux is there. Total number of armature conductors, speed of the armature, total number of poles, and total number of winding parallel paths. So these are the relations and correlations between DC machine with reference to stator and rotor, with reference to force, and with reference to voltage development or back EMF. So if the machine is working as generator, then voltage regulation is important. Type of characteristics, open circuit characteristics, internal characteristics, and external characteristics. These are important characteristics. By default, the generator rotates in clockwise direction and its direction can be reversed, that is by changing either field winding or armature winding, but not both at a time. Similarly, in case of motors, speed regulation is important. Type of characteristics, speed characteristics, torque characteristics, and speed torque characteristics. The direction of rotation of motor is by default in counterclockwise direction. The direction can be reversed by reversing either field winding or armature winding, but not both. Whereas in case of motors, starting, speed control, braking, and speed control below rated speeds, and speed control above rated speeds, these are important terms. Whereas in case of generator, starting, this is not a self-starting machine, so prime mover is required. Voltage regulation, parallel operation of DC generators, load sharing and load shedding. So these are the important concepts with reference to DC generators. So reversal of rotation is possible either by changing only either field winding or only armature winding, but not both. So whenever either field winding or armature winding is reversed, then the torque will be negative. So initially the field current and armature current are inwards, so the torque is positive. If either armature winding or field winding is reversed, then the current direction in that particular winding will be reversed. So here, this is the initial condition, initially negative, this is also negative, this is positive, means only armature winding is reversed. In this case, initially armature winding is negative, this is also negative, this is indicating positive, means in this case only field winding is inversed. So in these two cases, the net torque will be opposite to previous torque. Previously this is plus, so now the torque will be minus. If this is the initial condition, field current and armature current, and this is the torque, if both are inversed, then the torque will be again positive. So for reversal of torque, we have to invert either field winding or armature winding, but not both. Then only the opposite torque will be produced in the rotor. So the current is flowing in opposite direction, so that torque will be negative. Motor will start rotating in opposite direction, but not immediately. So this is the rotation of the motor. Motor is rotating in counterclockwise direction. At this position, the torque is positive and the terminals are reversed, either armature winding or field winding. Then the torque will change immediately, but the speed will not change immediately. Speed gradually decreases from positive speed to 0 speed and from 0 speed to negative maximum speed. So at 0 speed, the braking will be applied. So this condition we will explain while discussing forward motoring mode and reverse motoring mode. So torque can change immediately, but speed will not change immediately. Speed will decrease gradually. So coming to characteristics, in case of motor, speed characteristics, torque characteristics and speed torque characteristics, these are important characteristics. Speed characteristics, speed with reference to armature current. Torque characteristics, torque with reference to armature current. Speed torque, one side it is speed, other side it is torque. So torque is also directly proportional to current. So to draw these curves, we have to refer our basics. Torque is inversely proportional to speed. Torque is directly proportional to armature current. Speed is inversely proportional to armature current. So first we are considering this speed and armature current. This is the armature current. For rated armature current, the machine is rotating at rated speed, but machine will rotate in counterclockwise direction because this is in motoring mode. So this is the rated speed and this is the direction of current. So this is ideal characteristics. But in practical condition, there is small armature resistance drop. The speed will slightly decrease. The DC shunt motors are almost constant speed machines. And the speed regulation is very good. That means from no load to full load, the speed is almost constant. The speed regulation is speed at a no load to speed at full load to the speed at a full load. So at no load and at full load, the difference is almost negligible. So that speed regulation is very good. So speed versus armature current, the curve is ideally horizontal. That means speed is almost constant, but speed is slightly bends downwards. This is because of armature resistance drop. So speed is almost constant. Speed regulation is very good. This is under forward motoring mode. Quadratic 1. So reverse motoring mode, we have to refer quadratic 3, that is reverse motoring mode. This we will discuss at the time of discussing power, torque and speed along with 4 quadrants. Torque versus armature current. The relation between torque and armature current is directly proportional. That means it is linear characteristics. If armature reaction is ignored, then this will be the curve. If armature reaction is considered, then this is the curve which starts at origin only, but the curve deviates slightly. This is also almost linear relation. This is the torque on the shaft curve. So this is the shift of curve because of frictional losses. So basically the torque versus armature current, that is completely linear relation. Torque is directly proportional to armature current, so it is linear relation. If armature reaction is ignored, this is directly perfectly straight line passing through origin. If armature reaction is considered, it is almost linear but slightly deviates, and the shaft torque, by considering the frictional losses, there will be shift of curve. So the general relation between speed and torque is inversely proportional relation, but torque and current relation is directly proportional relation. So that speed and torque curves are similar to speed and armature current curves. So this is speed and torque curve, and the relation between speed and torque is the torque is inversely proportional to speed. That means as the torque increases, speed decreases. So in the same graph, we are indicating load current, torque and efficiency. So efficiency will be maximum at a rated load. If the load increases beyond the rated load, then the efficiency will decrease. So mainly these are the important curves with reference to shunt motor. One is speed curve, torque curve and speed torque curve.